Assalamu alaikum and hello everyone. We are Group-08 and this is our mini project for BITS 2313 Data Communication and Networking. My name is Sufyan and I will be presenting the introduction and conclusion of our project. Let me first introduce my teammates, Sulaiman, Hussein, Saeed, Faisal and Abdulrahman. Let me start with the introduction. Our project is about designing and simulating a hybrid ICT structure for a company called BITS 08 SDNBHD, which includes the headquarters and two branches of its branches, Kolim and Skodia. In today's digital world, every organization needs an reliable and scalable network to work smoothly and securely. That is exactly what we focused on in this project, building a full network solution that supports all departments, both wired and wireless, with a strong connection. We carefully planned the equipment, network layout, and IP addressing using VLSM. Everything was configured and tested using Backtracer, including connect and access to the web server. By the end of this video, you will see how our design ensures that all departments are connected, operational, and ready to grow up in the future.
Assalamu alaikum everyone, my name is Hussein and today I'm going to explain about the two diagrams, logistic diagram and the network topology diagram. So for the first one, the logistic details, we have three locations, HQ in Shalom, branch 1 in Kolim and branch 2 in Skudai. Each one is divided by floors or buildings. For example, at HQ the second floor is for management and so on. We also listed how many wired and wireless devices are on each floor and gave each one a separate subnet based on its needs. Branch 1 and branch 2 are simple with service department and staff hostel at each. Now we'll move to the network topology diagram. We show how all branches are connected to an ISP router using serial links with /30 subnets. Inside each branch we assign different VLANs using VLSM to save IPs. For example, HQ has VLANs for each floor, like 2F management on 192.168.8.64/28. Kolim and Skudai also have VLANs based on building and purpose. So overall, we organize devices by floors and departments and then match that with a clear and efficient IP structure in the network diagram. Thank you.
So hi everyone, I'm Suleiman and I will do the VLSM. So firstly, we have the headquarter. It's carved out of the private block 198, that 168.8.64. And so secondly, we have the two other branches offices share a signal 10.0.0.0. So that one we split it equally into two, so into two networks. So for the QLIM, we'll take the 10.0.0.0, and for the SCUDAI, we'll take 10.0.1.0. So inside every site, we applied a variable length subnet mask. So each floor or house get exactly the number of addresses it needs with zero waste and zero gaps. So this table shows the considered result for this for our strategy VLSM. So we have for the headquarters, the first floor, we have the technical department, and their usable addresses, it will be from the 97 to 102. And for the second floor, which will be for the management department, they will have usable addresses from the 65 to the 78. And from the third floor, which is the surface farm, this will be from the 105 to 110. And for the fourth floor, we will have a suitable addresses from the 81 to 91 to 94. And for the QLM house, for this it will hold the surface department and the usable addresses. It will be from the 17 to 22. And for the for the second house for the QLM, house B, it will hold the staff hostel. This will have a usable addresses from 1 to 14. And for Skudai first house, which would be the staff hosted, this will give us usable addresses, which is from the 1 until 14. And for the ground floor, which will be the surface department, this will hold from 17 to 30. So this is all for this part, and now we'll leave it to the next person.
My name is Saidani and I'm going to be talking about the physical layout of our project. We will start with the HQ. In the HQ, we have a core switch. All of the floor switches are connected directly to the core switch using copper crossover cables. All of the wired devices are connected to the switches using copper straight through cables. So in floor 2, we have wireless devices, they're always connected to a wireless router, and then that wireless router is connected to the switch, as you can see here, while the wired devices are directly connected to the switch. In floor 3, all of them are wired, so they're directly connected to the switch. And floor 4, all of the wireless devices over here are connected to the wireless router. Branch 1, we have house A and house B. House A, all of the devices in house A are wired, so they're connected to the switch, and all of the devices in house B are wireless, so they're connected to the wireless router. In branch 2, same goes for the branch 2. All of the wired devices are connected to the switch 2, and all of the wireless devices are connected to the wireless router. We also have a server, a web server for any external access. That's it. Thank you very much for listening.
Assalamu alaikum warahmatullahi wabarakatuh. This is Abdurrahman Hani. In this presentation, I will present the device configuration of our network. First, I will explain the sample wired PC IP configurations. Also, then I will present the wireless notebook. After that, I will present the router interface settings. And finally, I will present the access point settings. We can see here a sample of a wired PC IP configuration. The IP addresses used and the subnet mask here is based on the VLSM file that my teammate Sulaiman did. Also on this slide, we have the information of a notebook device that connects to the wireless network floor 4. This is the IP address of it, subnet mask, and default gateway. We see that the standard channel is 2.412 gigahertz. Also, the security type is WPA2 personal. For the router interface settings, we create 4 different VLANs. Each floor in the HQ building will take only one VLAN. Then pass these VLANs to the core switch via only one physical link. And we need to make sure that the port in the core switch is in trunk mode to allow passing multiple VLANs via this link. After that, we need to pass those VLANs to each switch in each floor in the same way we did to the core switch. Finally, to connect the end devices in each floor, for example, switch floor 1, in port 02, we need to make the port in access mode and then specify the assigned VLAN to this floor, which is VLAN 10. So here in this access point settings, we have the internet connection type is wireless access point, the network mode is auto, the SSID broadcast is enabled, and the channel bandwidth is auto. In the wireless security, we set the security mode to WPA2 personal and the encryption to IES, and also we set the passphrase.
Hi, I am Faisal, and here we are going to do the connectivity test. We are using in this part device BCM1, which is in the headquarter of the second floor, to do the testing on all floors of HQ and on Column House A and B, and on Skodai ground floor and the first floor. The pictures here show that we are using ping command followed by the IP address of the device that we are testing, using the testing all floors of headquarter from the first floor to the fourth floor, having on all of them with successful run. And here, moving to claim house A and B, we are using the same device in the second floor of headquarter to test the house A and house B having successful running. Moving to Skodai, we tested the ground floor and first floor with the same command, which is ping, and having successful run. In the web server, we were able to access to external server successfully using the URL shown in the picture. And thank you. That's all from me.
And now let me start with the conclusion. To wrap up, our team successfully designed and implementation the full ICT network for the ITS-08 SDN-BHD, connecting the headquarters with the 2 branches using an efficient IP addressing plan and clear topology. We provide devices connecting tested internet access and showed how every department is linked. This project not only meets the current needs, but also created a scalable solution that can go up with the company in the future. As a future improvement, we recommend adding network security tools, make the network more secure. Thank you for watching our presentation. We hope you found it clear and informative. Thank you very much.